very good evening to all of you. Okay, so just let me know that my voice is audible to all of you or not. So good evening Shagufta, good evening Gopinath, good evening Saksham. Okay, ma'am, physics in COMEDK is difficult or easy? So definitely dear, I find according to me, what I observed is COMEDK lectures are little bit COMEDK questions are slightly on the higher side as compared to KSET. Okay, it's not that very difficult as of your JE level, but yes, somehow you can say that it will be little bit on the higher side. Okay, next Damodar ma'am, could you please make a video about the deleted syllabus for COMEDK? Yes, definitely dear, we will make. Okay, so very soon we will make a detailed video on this one. Okay, so students are joining. Hello Arya, hello Over Geared Gaming. So yes students, let's start the class. So I'll be giving you the questions. You have to see the questions and then you have to write down the answers with putting question number, right? 1, 8, 2, 3 like that. Okay, so Shweta Chandran ma'am, apart from PYQs, what questions to solve to get 120 plus? So Shweta, you can solve NEET level questions. Okay, some for chapters NEET questions you can solve for physics and chemistry, and for maths definitely you can do some other books like MTG book is there, that practice questions you can solve. Okay, hello Shiri, hello Vaishnavi, Aditya, hi everyone. Aspia, ma'am, make a video on COMEDK mark versus rank. So Aspia I have already made for top 10 colleges, top 5 colleges. Okay, and last year also I made on top 20 colleges. So but definitely we will make it again. Okay, but if you want for now, you can check, it is already there in our channel. Okay, yes, so Shagufta ma'am, are you solving chemistry PU1 question? So dear, we will solve for PU1 as well, but today we will be doing D and F block chapters. Okay, Over Geared Gaming ma'am, are these questions enough for Manipal entrance exam as a practice till ma'am? Yes, definitely for Manipal entrance exam also you can practice this one. Okay, Vaishnavi, COMEDK is moderate level, little bit higher from KSET and lower than JE. Okay, Monish Goda ma'am, do Tukka strategies. Dear, we have already made a video on that, but yes, we'll come up with more examples and more videos on that. Okay, okay, so students, safe mark for COMEDK, Madhushri, you can all basically target 130 plus or 120 plus is a safe mark. Okay, yes, hello Chauhan, then Ichara, hi ma'am, hello dear. MH26 सार्थक मैम, केमिस्ट्री के लिए कौन सा बुक बेस्ट है? सो डियर, फॉर केमिस्ट्री यू जस्ट फॉलो NCERT and do previous year questions and do practice questions with us. That will be more than enough. Okay, okay students, so now let's start. We have a lot of students waiting, let's not waste time. So the first question is here in front of you, that is when SO2 is passed through acidified K2CR2O7 solution, what happens? So if you remember, K2CR2O7 is a strong oxidizing agent, right? So it will definitely oxidize other elements and itself it will get reduced, right? So what will be the product here? Can we guess? 1D. Shagufta has given the correct answer here, definitely. So now you see that CR is in +6 you can see, yes, it is in +6 state, it gets converted to Cr +3, and Cr in +3 state is a green color solution. So here we will have green Cr2SO4 is formed. So that is why option number D is the correct answer. Okay, yes, those who are saying SO2 is reduced. Okay, yes, that is, see, SO2 is actually oxidized. Okay, what is reduced? K2Cr2O7 is reduced. Okay, so that is the option number C is not the correct answer. Next, the first ionization energy of the elements of the first transition series, that is from titanium to copper. So if I move along the period from titanium to copper, what will be the order for the ionization energy. So students, please mention with question number, okay, 1A, 2B, like that. Please mention the question number. So yes, increases as the atomic number increases, decreases as the atomic number increases, do not show any change, increases from titanium to manganese and then decreases from manganese to copper. No. Now see, along the period, okay, along the period as Z effective will increase. Why Z effective will increase? Because the atomic number increases, so ionization enthalpy will also increase. So increases as the atomic number increases. Okay, 2A is the correct answer. Clear? Next, students, question number 3, lanthanoids and actinoids resemble in. So what is the similarity in between them? Yes. Is it electronic configuration, oxidation state, ionization energy, formation of complex? What is the I can say similarity between them? Can I answer? Can I get answer for question number 3 now? Yes. 3D. No. So students, see, the transition elements form complexes. Lanthanides and actinoids do not form that many complexes. They resemble in electronic configuration. Their general electronic configuration is same, right? I can refer all the N-2F, then I have N-1D and NS, right? 1 to 14, 0 to 1 and NS 0, 1, right? So this is the electronic configuration. So they have the, yes, so 3A is the correct answer. So their electronic configuration is similar. Okay. Next, in the chromate anion Cr2O7 2 minus, what is about the bond structure? Okay. Saksham, yes dear, this is obviously correct. This is obviously sufficient. Piyush Kumar, no, all the options are not correct. See, lanthanoids and actinoids resemble in. So you have to tell what is similar in between them. Means how do they resemble? They are equally or exactly equal in what things. So their electronic configuration is the most appropriate answer here. Okay. Next, fourth question, Cr2O7. So if you see, this is like this. This is Cr2O7 2 minus. Okay. So I have like this. Right. So now you can see that these bonds are in resonance, right? Chromium, these bonds are in resonance. So I can say that 6 bonds here, 1, 2, 3 and 4, 5, 6, they are equivalent, but these CRO and these CRO are not equivalent. So total I have 6 CRO bonds which are equivalent. So 4B is absolutely correct. Okay. Next, question number 5, which one of the following ionic species will impart color to an aqueous solution? So what is the basic rule to have a colored solution? For color, what I need? For color, we need DD transition, right? And when do DD transition will take place? If I have unpaired electrons, right? So now if you see that which of the solution will have unpaired electrons. So scandium, titanium. What is the electronic configuration of titanium? It is argon for 3D2 and 4S2. So titanium 4 plus, you will have only argon configuration, no unpaired electron here. Zn2 plus has D10 configuration, no unpaired electron. Cu plus has D10 configuration, no unpaired electron. Chromium. Chromium, if you see, it is 3D5 and 4S1, and chromium 3 plus will have 3D 3 electrons. So 3 electrons are present which are unpaired. So definitely this one will be the correct answer. Okay. Next, question number 6 here. Can we answer question number 6? Yes. So the metals of group 12 elements are softer than other transition elements. Now group 12, you should know which one. That is your zinc, cadmium and mercury. Okay, group 12 before the aluminium family, the last group. So that is why are they softer than the other transition metals? That is because they have a cage-like structure, they have high ionization energy, the S as well as D electrons take part in metallic bonding, D electrons do not take part in metallic bonding. Yes. 6 is D here. Yes, absolutely, all of you are correct. Now you see, because of D10 configuration, okay, 3D10 configuration, what happens here? 3D10 configuration is there, so it is fully filled, right? So there is no unpaired electron for intermetallic bonding. So there is no unpaired electron, so that is why we will have no metallic bonding and they are very soft. Next, question number 7. Which of the following transition metals of 3D series has the lowest melting point? So if you remember, very important question, lowest melting point. If you remember the graph of melting point, what is the lowest? This one. 7th is D. Yes, definitely manganese, option number D. So Piyush, can you teach in Hindi language? So dear, in this channel we are using completely English. So in our crash course we are teaching in English, that is Hindi and English we are mixing. So you can take the crash course, but in the channel we are bound to use the English. Okay, in YouTube channel we have to use English language only. Okay, so 7th one is D. So you know what happens again, manganese has D5 configuration, which is stable half filled configuration. Okay, stable half filled configuration. So whenever a configuration is stable, what does that mean? It means it is attracted towards the nucleus, attracted towards the nucleus. Okay, so it is very close to the nucleus and it cannot participate in the metallic bonding. So if there is no metallic bonding, there will be less melting point. So option number D here. Okay, next, question number 8. Choose the correctly paired gaseous cation and its magnetic moment. Yes, this is also very easy question. Yes, what will be the answer here? Priyanka is saying B. Priyanka, please write down with the option. Yes, Sweta. Okay, so I will want to tell you one thing. So if the number of unpaired electrons is 1, the magnetic moment will be 1.7. For 2 it will be something 2.8. For 3 it is 3.8. For 4 it is 4.9, and for 5 it is 5.9. You can remember like this. Okay, now scandium, titanium 2 plus. Okay, that is 3D2. Right, so 3D2 will have 2 point something, it is given 3.87, so that is wrong. Chromium 2 plus will have 3D4, again 3D4, sorry, yeah, 3D4 means 4 unpaired electrons, so 4.9, option number B is the correct answer. Okay, next, gadolinium belongs to 4F series, its atomic number is 64. Which one of the following is the correct electronic configuration of gadolinium? Correct electronic configuration. Priyanka is super active today. So 9B, yes, Xe4F7 5D16S2 is the configuration of gadolinium. Yes, very good. Madhushri, Saksham, Arya, all are good. Next question. Which of the following is an amphoteric oxide? Now what is an amphoteric oxide? Those oxide which can react both with acids, okay, and bases. They can react both with acids and bases. So those type of oxides are called as amphoteric in nature. So what are the oxides which are amphoteric in nature? Okay, yes, oxides which are amphoteric in nature. Can I have the answer here? Let's see who is answering. 10, A, B, C. I am getting so many options here. Yes, so the correct answer here is Cr2O3. Okay, and for vanadium, remember V2O5 is amphoteric in nature, not V2O3. Okay, Cr2O3 is amphoteric in nature, so option number B. Yes, Shweta, intermediate oxidation state. So let me just tell you, if you have high oxidation state, then it will be acidic in nature. Okay, and if you have low oxidation state, then it will be basic in nature, and you have intermediate oxidation state, then it is amphoteric in nature. Okay, generally. Next, the metal ion present in insulin. Okay, so this one is a good question on the basis of its application. So which is present in insulin? 11A, Priyanka has given correct answer. Yes, Zn2 plus is present in insulin. Next, cuprous ion is colorless while cupric ion is colored because. Now cuprous ion means Cu2 plus, okay, and cupric ion, cuprous is Cu plus and cupric is Cu2 plus. So they are saying that Cu plus is colorless but Cu2 plus is colored. So if you remember, Cu plus configuration is D10 and Cu2 plus configuration is D9, right? So what can be the correct answer? Yes, 12D is correct. Cuprous ion has a complete D10 orbital and cupric ion has incomplete D orbital. So option number D here. Next, the correct order of ionic radius of Y3+, La3+, Eu3+, and lutetium 3+. Now see, in this question you might not be knowing all the elements position because we don't generally remember the the order of the lanthanides, but you should know one basic thing, that lanthanum is at the starting and lutetium is towards the end. Okay, so this is along the same period. So definitely lanthanum will have the largest size, and lutetium and this one it may vary, but lanthanum has to be at the largest size because along the period the size decreases, right? So I have only one option where lanthanum is having more size. So which one has to be the correct answer here? Yes, B is the correct answer, option number B. All of you are correct here. Next, question number 14, equivalent mass of K2Cr2O7 in acidic solution. Yes, equivalent mass. What will be the equivalent mass here? See, what is the formula of equivalent mass? Equivalent mass is equal to molar mass, okay, divided by N factor. Now, if I have K2Cr2O7 in acidic medium, what happens? Cr2O7 2 minus get reduced to Cr3+. Now, oxidation state of chromium here is +6, and if you see 2 chromiums, then I'll make it 2 Cr3+. So +6 to +3. Reduction is happening. So we have 6 electrons here. For 1 chromium it is 3. I have 2 chromiums, so 6. So what is the equivalent weight? Molar mass, molar weight divided by 6. So it is molecular mass by 6. So option number D here. Yes, all of you are correct. Next, which of the following compound on reaction with NaOH and Na2O2 gives yellow color? Yes. Can you see this question? Which of the following NaOH and NaO2 will give you yellow color? Yes, students. Priyanka has the answer. Shagufta is saying A. Okay. All of you, please answer this question. Saksham is saying C. Okay. So I'll tell you the reaction first. The answer, the reaction is like this. If CrOH3, okay, reacts with NaOH and Na2O2, you get CrO4 2 minus. Okay, the product formed is CrO4 2 minus, and this one is a yellow color compound. Okay, so the chromium hydroxide will react with NaOH and Na2O2 to give you chromium chromate CrO4 2 minus. Okay, 15C is the correct answer. Next, which of the following shows maximum number of oxidation states? This is also very simple question. Maximum number of oxidation states are shown by, yes, 16th C. Yes, manganese shows the highest oxidation state, and the highest oxidation state is also shown, that is +7, and in the whole series it has the maximum number of oxidation states from +2 to +7, right? Next, in 3D series, as we move along the scandium to zinc, the paramagnetism behavior. So what is the nature of the paramagnetism? It increases, it decreases, first increases to a maximum and then decreases, first decreases to a minimum and then increases. Yes, 17, I can see floods of answers with option number C. Yes. So if you know the configuration, we have first D1, D2, D3, D4, D5, right? Then D6, D7, and then I have D8, D9 and D10. So this is 1, 2, 3, 4 and 5. Now D6 will have again 4 number of unpaired electrons, 3, 2, 1 and 0. Right? So as we move from along the period, the number of unpaired electrons first increases and then decreases. So if the number of unpaired electrons first increases, magnetism will increase and then again it will decrease. So option number C here. Okay. Next, which one of the following characteristics of the transition metals is associated with their catalytic activity? How can we discuss or tell about the catalytic activity? Yes, catalytic activity. 18D, yes, variable oxidation states is one of the reason, and you also have other reasons like empty d orbitals, right? So you should remember all the reasons and their ability to form complex ability to form complex. Okay, so these are the different characteristics which contribute or attribute towards the catalytic activity of transition elements. Next, platinum, palladium and iridium are called noble metals because, so this is very easy question, basic definition of noble metals. Okay. Next, question number 19. Yes, because they are inert towards many common reagents. Yes, so noble metals are those metals in general which do not have much reactivity, right? Yes. Next we have question number 20. When chromyl chloride is dissolved in water, what do we get? So chromyl chloride is dissolved in water, then what is the product formed here? So first of all, what is chromyl chloride? CrO2Cl2, and it is dissolved in water. So what will be the product here? Anyone? 20A. Yes, so because we get the product here H2CrO4, okay, and this is called as your chromic acid. Okay, H2CrO4 plus HCl is formed. Okay, so we will get chromic acid, option number A. Okay, next, Sharu, I will answer your question at the end of the session, so please do not spam now. I'll answer your question. Okay, pick out the wrong reactions. Okay, you have to find out the wrong reaction. So CrO4 in presence of H plus gets converted to Cr2O7, that is the correct reaction, right? Next, MnO4 with KOH in alkaline medium gets oxidized to give you K2MnO4, right? Not KMnO4, so this is a wrong reaction. Then Fe2 plus to Fe3 plus, this is correct. C2O4 to CO2, this is also correct. So the incorrect one will be option number B here. Yes, all of you are correct. Next, mic metal is, so this is also a very easy question. All of you might be knowing what is mic metal. Mic metal will be an alloy of lanthanoids, right? Yes. And here you should remember we have 5% of iron. Okay. Next, 23. With sodium hydroxide, silver nitrate forms a black precipitate of. So what is the black precipitate that is formed when silver nitrate, that is AgNO3, reacts with sodium hydroxide? Yes. What is the black precipitate formed here? Yes, the answer here is silver oxide. This, remember please, the color here, this is black precipitate. Okay. Next, silvering of mirror is done by. Silvering of mirror means when you already have a mirror, okay, to make it more shiny or something, we put a coat of silver on it. So how do we use, or which reagent is used to do silvering of mirror? Yes, for silvering of mirror we do AgNO3. Now see, what you do exactly is you coat this with AgNO3. Okay, now you put a reducing agent here. Okay, anything which can reduce Ag plus, any reducing agent. So what will that do? Ag plus will convert to Ag, right? And that Ag will be deposited on the mirror, making its more shiny and lustrous appearance. So what is there used? AgNO3, that is option number A here. Yes. Next, which is a non-lanthanide element? Very, very tricky and an interesting question. Which of the following is a non-lanthanide element? 25th A. Yes. So now you see that lanthanum, okay, lanthanum is actually our first element of 4D series. After lanthanum, the next 14 elements, they actually belong to lanthanoids, okay. But lanthanum, since it is a starting element of the series, starts from here, but this is not a part of lanthanum elements or lanthanoid series. So that is why option number A here, okay. Yes. Next, we have question number 26. Brown's catalyst is. This is a good question. Brown's catalyst. Yes, let me see how you can make a guess here and tell me. Yes. So here brown catalyst is nickel boride, okay, and it has a similar reaction as like Wilkinson catalyst. Okay, so we have a catalyst called as Wilkinson catalyst. It has a properties or function similar to Wilkinson catalyst. Okay, yes, and what is this used for? It is used for hydrogenation reactions. Okay, hydrogenation reaction. Clear? Okay, I hope this is clear to all of you. Let me see. Yes, 26th B, those who are saying that is the correct answer. Okay, next 27, more number of oxidation states are exhibited by the actinoids than by lanthanoids. The main reason for this is, main reason for this will be, yes, anyone? What is the main reason for this one? 27, I have already got D as answer from Shagufta and Sweta. More energy difference is there, less energy difference is there between 5F, 6D orbitals than 4F and 5D. Yes. So students, why the lanthanides or the transition element shows variable oxidation state? Because the last orbital and the previous to last orbital, these all can participate in the bonding because of very less energy difference. So in the case of lanthanoids, 6D and 5F have very less energy difference. So all the electrons present in 6D and 5F can participate in the bonding. So that is why option number D. Okay. Next 28th, a transition element with atomic number 24 will have a magnetic moment. Very, very good question. Atomic number 24, that means chromium, right? Chromium has an electronic configuration of 3D, 5 and 4s1. Number of unpaired electrons here is 6. So for 6, what will be the atomic? Yes, so for 6, it will be 6.93. So option number B. Okay. Yes. 29, in tetrahedral permanganate ion, the pi bond, this is actually pi bonding. Okay, the pi bonding type between the metal and the oxygen. Permanganate ion, if you see KMnO4, right? 1 second. MnO4 2 minus, right? MnO4 2 minus. So here this pi bond, the present that is between manganese and oxygen, this pi bond is due to what? So this pi bond is due to, yes, what is the answer? 29B, yes, due to the d pi p pi bonding, means metal d orbital and oxygen p orbital participate in the bond formation. Okay, next last question, which of the following pairs has the same size? So which of the following pairs will have the same size? Can anyone tell me this? Same size will be present in between? Yes, 30C, zirconium and hafnium. And what is the reason for that? Why do they have same size? Can anyone comment and tell me the reason for that? What is the reason for this? Yes, I want to see the reason. Yes, Shweta has given lanthanide contraction. Yes, definitely. Due to lanthanide contraction, the size of the atoms shrink, right? Yes. Lakshu, in COMEDK, you will cannot carry the calculator. It is an online exam. So in your desktop or like in your system, there will be a calculator attached. Okay. Yes. Okay students, so these were the top 30 questions from D and F block. Okay, and I want to tell you, if we have already launched our crash course program, and if you are interested, if you really want to prepare full-fledged preparation, PU1, PU2, 11th and 12th syllabus entire coverage you want to do, you want to attempt 12 mock tests are there. So if you want to boost your preparation, then definitely you can take our COMEDK test crash course. The link is there in the description section. Already thousands of students have purchased, and they are always like already made up their preparation much better. Okay, so if you want, then you can also do it. Okay, Anand Mayur Maurya, the next chapter is what? Okay, Saminathan B. Okay, next chapter, dear, we have already, this is a continuation of COMEDK Launchpad, the free YouTube series that we have already started. So there we have already completed your what I'll say, physical chemistry and organic and inorganic. Now we will be going to PU1 chapters. So I'll be telling you soon the next chapter. Okay. The Too Bright, thank you ma'am, thank you so much dear. Okay. Saminatha ma'am, can I join your class tomorrow? Dear, which class you are talking about? If you're talking about crash course, then first you have to register, you have to purchase, then you can join. Okay. Okay, so students, if you have any other question, do put down. And yes, Saminathan, you can join it from tomorrow, no problem. Only few classes have been done. Yes, Arya, we will continue with the organic chapters. Okay. Yes. Okay. Thank you students, that's all in this class, and I hope this session was helpful for you and you have understood the level of the questions that is being asked in COMEDK. Definitely it is slightly higher than KSET, but not that difficult. As also, if you prepare from now, we have almost 21 days left. If we prepare properly, you can get the good rank. Okay. Yes. Saksham Gupta, you can definitely score 100 marks. You have to target, at least just imagine like which is your strong point. Okay, so in chemistry you can easily score 45 plus, that is achievable. Okay, and you can mix maths and physics according to your strength and weakness, and target in which subject you want to get how much. Like suppose maths is your weak, you can keep 30 or 20 something in maths, right? And if physics is moderate, you can target like that. You have to this one. Okay. Shagufta, thank you, session was amazing. Thank you Shagufta, thank you so much, all the best for your exam. Yes. Okay, that's all students, and see you soon in the next class. So tomorrow we will have physics live, same at 4:30 p.m. and sir will be taking the COMEDK PYQs on the chapter that I don't know. Basically you will be getting in the notification of our channel. So after that again it will be continuing in a cycle, maths, chemistry, physics, maths, chemistry, physics. Okay. Yes. Okay, so students, that's all, and thank you all of you, and bye bye, take care.